Hello students, welcome to another short video on our Small Steps Good Grade Secondary Science program. Today we are going to do physics, current, electricity, and we will be using some school paraphrase exams questions and also Cambridge GCE O-Levels question. Let's go! So the first one says that the graph shows the result of an experiment to determine the resistance of a wire. So I have voltage and I have current. So what formula comes to your mind? The formula should be V is equals to IR. Ohm's law, right? Therefore, you'll have resistance is equals to voltage over current. Okay, and hence you will realize that when a graph is given, resistance is actually the gradient of the graph. And the answer is C, because 20 divided by 4. Where do you get 20 volts? The 20 volts is here, right? When it is 20 and the current is 4, you will have 5 ohms, right? What if I didn't use 20? You can actually use 15 and you will also get 5 ohms, all right? Let's move on to the next question. Now, a length of wire 0.5 meter having a cross-section area of this and has a resistance of this. Another wire has the same material and has a length, I think 4 times, because the previous one is 0.5. So this one is 2, so it has 4 times longer in length, and the cross-section area seems to be half. Okay, so this is 1 times 10 to the power of minus 6. This is half times 10 to the power of minus 6. What is the resistance of the longer wire? I want to share with you folks. Please, when you see this type of question, this formula must come to your mind. That is, resistance is equals to resistivity length over area. Now, this resistivity depends on the material. Therefore, it says that it is using the same material. So this one is the original one. And let me give you a guideline of how to do this type of question first before I review the answer. All right. So you can have the original resistance as R original, and you will have resistivity and length original over area original. Okay. Now, when you want to have the new wire resistance, you have resistivity, the length of the new over the area of the new. What's the length of the new? The length of the new is 4 times the length of the O, okay? And the area is actually half of the original area, okay? So let's move this around and you will see that 4 divided by 2 is actually 8. So what is this? This is actually the original resistance, which is 0.75. All right? So for this case, they actually calculate the resistivity first. However, you don't calculate the resistivity and still use the ratio way, and you can find out that 8 times 0.75 is equals to 6 ohms. The next question, the circuit diagram shows 3 resistors in parallel with a battery. What is the effective resistance of these 3 resistors? Now, effective resistance is total resistance, okay? So, total resistance across these 3 resistors. Now, in parallel, please know that you have to apply this. If there are 3 loops, you have to apply 3 fractions, all right? So same, there are 4 options given. Go and do your calculation and check whether you get the correct answer. The answer is B. Just plug inside the formula and you will get 0.57 to 2 significant figures. Now, The next question. Electric fence are used to keep some animals on the farm in their enclosures. Okay, so this figure, you will be able to see that voltage is given 12 milliampere. Okay, so you have to take note of the prefix. And let's take a look. What do they want? The activator produce short voltages pulse in the wire. So the pulse is 950 volt. If an animal touches the wire, the pulse carries an electric shock with an average current of 12 milliampere that makes the animal move away. So each pulse actually delivers 6 joules. Okay, so you have a lot of information. Now calculate the average power. Okay, so before you watch on, you can pause here and see whether your calculation is correct. Okay, so for power in electricity chapter is always equals to current times voltage. Check whether your current is given, your voltage is given, and make sure everything is in their SI units. And there you have it, 114 watts. Now calculate the length of the time of each pulse. Another formula for power is equals to energy over time. So since you already have the power, 114, and you have the energy given in the previous slide, you just do a cross multiply, solve, calculate the average charge. Charge has two formulas, Q is equals to IT, or V is equals to work done over charge. Okay, let me write down for you. So for charge, please think of these two formulas. Voltage, okay, is equals to work done or energy over charge. All right, so you have quite a lot of information given. And the one most obvious is the time, and you have the current also given in the question. So you just solve it using Q is equals to IT. And there you have it, 6.4 times 10 to the power of 4 coulombs. 6.4 times 10 to the power of minus 4 coulombs. Now, this is a school paraphrase exams question. So this incomplete circuit below shows how several fixed resistors are connected. Point A and B are connected to a 9-volt cell, and the arrow indicates the direction of the flow of electrons. Do take note, conventional current is in the opposite direction of the flow of electrons. Okay, so let me write down for you. So this way is the direction of the conventional current. So I believe the positive terminal is here and the negative terminal is here. Okay, complete the drawing. Oh, by drawing the cell. So I have already shared with you. A is the negative terminal, B is the positive terminal because of the convention current flow. Now calculate the effective resistance now for the whole circuit, not only the parallel portion. So this is a combi circuit. Combi circuit means there are series portion and there are parallel portion. So usually for combi circuits, right, we will try to draw it into a series circuit. All right, so basically I'm going to show you how I will usually ask my student to redraw this. If this is B, this is A. So coming out from B, I will hit the 3 ohms resistance first. Then I will hit the parallel portion. Please make sure you go and find the effective resistance for this parallel portion first. This is 1 and this is 2 ohms. Okay, using the 1 over RT is equals to 1 over 1 plus 1 over 2 formula. Then you will also hit the 4 ohms. Then you go back to A. Okay, so like that, you can see that, oh, it's actually a 2-2 train series. Okay, just that in the series circuit, there is a parallel component. Okay, so let's go and calculate this one first. over 1 over RT, which is only for this portion, is 1 over 1 plus 1 over 2, which is 3 over 2, right? Because it's 1.5, RT will be 2/3 ohms for this portion, okay? This portion only. Then you have to cut, and then you have to add 7 because 3 plus 4. So therefore, you'll have 7 and 2/3 ohms, or 7.67 ohms. So hence calculate the power dissipated. There is 2 formulas, so please take note. P is equals to IV, or P is equals to energy over time. So when you do current electricity chapter, please make sure you have all this information in your head. We actually have this portion, which is 9 in the previous question. This, you can actually get it by using voltage over resistance. And therefore, here is P is equals to V over R times V, which is also equals to VR over resistance. All right? And there you have it, 10.6 watts. D, the 2 ohms resistor is removed. State what happens to the current flowing through the 3 ohm resistor. Let's go back and take a look. Where is the 2 ohm resistor and where is the 3 ohm resistor? So the 2 ohm resistor is removed. So when this is removed, okay, when this is being removed, you will actually have a very beautiful parallel. You will actually have a very beautiful series circuit. So this is 3, and then this is 1 ohms, and then this one is 4 ohms. Okay, my ohms not very nice. Okay, so you will realize that when there is no parallel portion, the total resistance will increase. And when the total resistance increase, the total current will decrease. The diagram below shows a label of an air conditioner, which is connected to 230 volt AC grid. Now, calculate the rated power of the aircon based on the label. So what do I have? I have voltage here, frequency, all this I don't need. Weight, I don't need. What do I have? Oh, I have this current. Okay, and there you see. So you will have P is equals to IV. On average, the aircon is turned on 4 hours per day. Calculate the cost. So this is actually in practical electricity. Okay, when we calculate electrical energy, we no longer use watts times time. We use kilowatt hour. All right, because the electrical cost or tariff is always in kilowatt hour. Okay, power is equals to 759 watts, which is equals to 0.759 kilowatts. Okay, so 4 hours, the energy in kilowatt hour will be 0.759 times 4, and therefore you will have the energy in kilowatt hour. And then you times this, which is the cost for 1 day, and then you times 365 days, and you will have the answer. So 0.759, you times 4 first to get the energy for a single day. And then you times 365 days to get the energy for the whole year. And then you times the cost per kilowatt hour. And you have this $216. The aircon is fitted with a fuse. State the rating suitable. So the rating suitable, the current, right, is actually 3.3. So the rating suitable will need to be slightly higher. You cannot buy a fuse that is 3 ampere, because whenever a 3.3 ampere current flows over, the fuse which will melt, and it will create an open circuit. So you need a slightly higher ampere rating in your fuse. All right, we have come to the end of today. short video on current electricity. So feel free to clarify anything with us if you're on our Small Stats Good Grades program. Bye-bye.